Good morning students. So welcome back to digital signal processing class. In today's class we are going to continue the concept that is nothing but the part of unit 3 we are going to start. In that it's a continuous part, we just want to proceed, that is nothing but IR filtering, but here we are going to design the filter by using the impulse invariant or bilinear transformation, and we need to get the block of it. So we will take one problem, they'll give one particular equation. So now here equations are given, that equation we need to draw it into particular output form. So this is a question, realize y of n. So we had the question, so realize y of n plus y of n minus 1 plus, so y of n plus 1 plus 1 by 4 y of n minus 2 is equals to x of n. So realize this, y of n plus y of n minus 1 plus 1 by 4 y of n minus 2 is equals to x of n in cascaded form. So in cascaded form. So this is the question, we need to realize this particular question into cascaded form. So basically we should know how do we design it, what are the parameters that we need to consider for writing in cascaded form. So for writing anything in cascaded form, first thing you have to keep in your mind the given differential equation or the given equation we have to first convert into n domain to z domain. So in this, what is given, they give in n domain, that we need to convert into z domain. So we are converting n domain sequence into z domain sequence. So what I can write, first thing I'll apply z transform for it. So applying, first you'll write given. So what is given? So given here y of n plus y of n minus 1 plus 1 by 4 y of n minus 2 is equals to x of n. So we need to convert into n to z domain. What we will do it, we'll write applying z transform on both sides. So we just want to apply z transform on both sides so that it will be going to convert into n domain into z domain. So I can write z of y of n plus z of y of n minus 1 plus 1 by 4 z of y of n minus 2. Likewise z transform of x of n, right? This thing we wrote it. So now what is z transform of y of n? I can write it as y of z plus, here delay sequence is given n minus 1. So what we'll write, we'll convert into y of z into z power minus 1. So since one delay, we will write z power minus 1. What about here? We'll write 1 by 4 as it is, z transform of y of n minus 2. So how do we write this thing? We can write y of z into z power minus 2 is equals to x of n, I can write it as x of z. So this thing we wrote everywhere, whatever the given values we do have, we convert into z domain. Next thing, we have to get the transfer function. So basically what is the transfer function? H of z is equals to output by input. That is called transfer function. So you may get this thing in your automatic control system also, right? We need to get a transfer function for any given system in order to understand the performance, in order to get the how it is going to work. So in order to get this output by input, if you divide, you will get the transfer function. So we have to get the transfer function for this particular given condition. So we have to convert into this transfer function. So what I can take for these three terms, I can take y of z common. So I may get here 1 plus here z power minus 1, here I do have 1 by 4 z power minus 2, right, is equals to, I can write it as x of z. So I'll shift this x of z on right side so that I'll get y of z by x of z is equals to, I can write it as, what is left here, 1 by this factor will be go over there, so it will become 1 plus z power minus 1 1 by 4 z power minus 2. This way I can write. So what I can write for the first factor, this is there in all the ways. So I can write this as 1 by, I can write this as 1 square plus 2ab, 2 into 1 by 2 into z power minus 1 plus I can write this as 1 by 2 z power minus 1 square. I can write, so what I did students, I multiply and divided by 2 for this factor. So it will become a square plus 2ab plus b square, right? What is b value? B value is 1. So what is this particular form? A square plus this is 2 add for the formula. So this is our b we do have. This is our a. So ba plus b square. This I can write as a plus b whole square. So this factor I just want to convert. So in that what I did, so till now what we have done, students, so we need to given condition we need to take y of n is given plus y of n minus 1 plus 1 by 4 y of n minus 2 is equals to x of n. The question is to write into which form? Cascaded form. So that part we will do it. For doing this thing what we did, we apply z transform on both sides. So z transform of y of n is y of z. Z transform of y of n minus 1 is y of z, z power minus 1. Plus 1 by 4 y of n minus 2 is y of z, z power minus 2 is equals to x of z. So I can take y of z, y of z, y of z common. I took it here, what we left here 1, here z power minus 1, here 1 by 4 z power minus 2 is equals to, here we got it as x of z. Next we have to get what? In order to write in cascaded form, we have to get the transfer function. So transfer function is given by y of z by x of z. So output by input. So that's the reason y of z by x of z I did, we got this factor in denominator. Next thing, I just want to make into standard form, or else I can go for partial fraction, or it is a quadratic equation, you can find the roots of it. So but I get this logic here, so I am applying it. 1 square plus 2, I am multiplying dividing by 2 for this factor. So we wrote it plus second factor. This I can write 1 by 4 is 1 by 2, z power minus 2 I can write z power minus 1 whole square. So next thing I can write this as a plus b whole square. So we have to write that particular a plus b whole square and we can find the value for it. So we will write down a plus b whole square for this factor. So we get y of z by x of z, what is the value, students? So we can write as, I can write this as what? I can write as h of z. So h of z is equals to what I got here? 1 by 1 plus 1 by 2 of z power minus 1 whole square, because it's whole square of this factor. So whole square I can write as h of z. So h of z is equals to, I can write 1 by 1 plus 1 by 2 z power minus 1 into 1 plus 1 by 2 z power minus 1. So I got this factor. Now what I need to do? I need to write into cascaded form. For doing the cascaded form, what we will do? We have to design this factor. So what is this factor? This is the delay sequence, right? So we do have, this is a multiplication sequence. So now next thing what I am doing, I am designing the cascaded form. Cascaded form of given transfer function. So this part I need to do. So for doing this thing what I am doing, I got h of z. Next thing I need to find the value for it. So I just want to write into cascaded form. I got h of z, I can find easily. So here both the end I do have amplitude, we got it. So we can write down this thing. So what is the things we need to do? We have to first give input. What is the input? X of z. What is the output? Y of z. So basically we will draw that one. First we are giving input x of z, right? This is the input. So then what is the output we do have? We do have output is y of z, right? So in input what is the thing we need to write? First this particular factor. What is that factor I can write? I'll convert into two parts. One part is this way, another part I do have one more addition of it. Basically first I will do for this part. In this amplitude is 1 by 2. So plus means we will take what? Minus. In the previous class also I said you, whenever we do have poles, we equate with 0. So we got minus 1 by 2. So what is the delay factor we do have here? Delay is z power minus 1. So what is the multiplying factor? Minus 1 by 2. It is passed to this thing. So what we did, students, so what we have done right now, we just want to design this one into cascaded form. Cascaded has this factor and this factor. So we got with first factor amplitude minus 1 by 2 z power minus 1, we wrote it. Now for the second factor, what is the same value? We need to write the same factor by using this phenomena. So what we are writing? We got this for second part. For the second part what we will do? We will try to write the same factor by adding the part. So by adding this thing what I can write? I can write one more addition because we do have here addition for this factor. So I can write plus here, right? So what is the things we need to do? In delay what we are doing? This part is going over there, and in delay we do have z power minus 1. Again it is passing to this factor. So here I can write minus 1 by 2 for the second amplitude, right? So these two are called cascaded form of designing. So what we did? We designed this particular thing and this particular thing, and we got here amplitude minus 1 by 2 and amplitude minus 1 by 2. Then this is y of z, this is x of z. If you divide both of them, you will get the h of z. So this is the way you can design the given factor into cascaded form. So we just have to put the arrow here because we are passing from this end. So with this we put the arrow. This is the y of z or x of z. If you want to write it n domain, this same factor we can replace by n. So here I can write x of n and y of n. Right? So this is the complete answer of this given cascaded form. We will do more problem to get this idea how it is going to work. So we do have a next problem, students. So in the next problem they give convert the cascaded realization. Yeah, obtain the cascaded realization. So they gave obtain cascaded realization of the given function. So obtain cascaded realization of the function. We are taking h of z. So h of z is equals to, this is our question, h of z is 1 plus 3 by 2 z power minus 1 plus 1 by 2 z power minus 2 by the given factor is 1 plus z power minus 1 plus 1 by 4 z power minus 2 into the numerator we do have one more factor, we do have 1 minus 3 by 2 z power minus 1 plus z power minus 2 divided by 1 plus 1 by 4 z power minus 1 plus 1 by 2 z power minus 2. This is our question. So we have to obtain the cascaded of the following reaction, following given system. So for that we'll write h of z is 1 plus 3 by 2 z power minus 1 plus 1 by 2 z power minus 2, we wrote it. Then second factor we wrote, and we have to write the cascaded form for given condition. So for doing this thing what we will do, we will try to first write down the values. So it's 3 by 2 s minus 3 by 2 plus z power minus 2. So we just want to write for the given condition. For doing this thing what we will do, we will first write down this factor. The first thing we will try to make into two parts. So this is a question, right? So we have to make what? H of z is given. H of z is equals to, this is nothing but h1 of z I am saying. This is my h2 of z. Right? What is h1 of z I can write? Where h1 of z would be 1 plus 3 by 2 z power minus 1 plus 1 by 2 z power minus 2 divided by this 1 plus z power minus 1 plus 1 by 4 z power minus 2. This is my h1 of z, and h2 of z would be 1 minus 3 by 2 z power minus 1 plus z power minus 2 divided by 1 plus 1 by 4 z power minus 1 plus 1 by 2 z power minus 2. So this is our h1 and h2, we got it. So next thing, we need to design it. So for designing this thing what we will do, we will try to do h1 of z separately and h2 of z separately. We will try to write down those values by taking the separate factor. So for numerator separately and for denominator separately we will do it. So this thing is what we can write. So what is h of z, students? So h of z is what? Y of z by x of z, or if it is in n domain I can write y of n into x of n. If it all z also, you can write n also, because the input we can give is n only. As you can see in the previous problem, whatever the numbers we are giving, it is in n domain. So now what we will do, we'll write down these two factors first. What are the two factors I do have? First thing, give plus, and what is the input? x1 of n, right? So what is the delay sequence we are giving? We are giving z power minus 1 for first. For writing one more z power minus 2, what I'll do? I'll write one more plus, and again one more z power minus 1 I'll give. So what we are giving, this we are passing. So how do we are passing? By passing like this. What is the amplitude of this plus 3 by 2 means? It is what? Minus 3 by 2. This we are passing here, right? From this we got minus 3 by 2. What about this here amplitude? Minus 1 by 2. So this we are passing to this one. So till now what we did, this end we found out. What we found? We wrote it for the first factor and the second factor by giving this way. So by giving this way we can do it, or by giving parallel. Parallel if you give, it will be quite easy. So what I am giving, instead of giving in series form, if I will give parallel form, z power minus 1, z power minus 1, if you add you will get z power minus 2. For that what I am giving, I just want to write this factor into parallel form. So I can easily add up this thing. So series also you can go for it, and you can go for parallel. So better you try with parallel. So this thing, instead of series what I am giving, I am passing with z power minus 1 here. Similarly here, z power minus 1, this connection. Whenever we do have any connection, we have to add the summer. So for that what I am doing, I am adding a summer to this, and for passing this line I am adding one more summer. right? So what I did, I passed two values with the addition part. So this is the summer part we do have for the first factor and for the second factor. So what is the amplitude here? Minus 3 by 2 means this is also minus 3 by 2. So this summer part we need to add for the first part. So till now what we did, it is minus 1 by 2 means here also same minus 1 by 2, both the end you are passing. So this is the first circle is for minus 3 by 2 z power minus 1, we got it. Second factor 1 by 2 is here, z power minus 1 and z power minus 1. How it is? Z power minus 1 into z power minus 1 is z power minus 2 and the amplitude is 1. So I can write 1 by 2 z power minus 2. This is for the second factor. Similarly for the second h2 of z. For h2 of z what I'll do it? They asked in which form? Cascaded means both should be in a same, in a one function only. For that what I'll do it? I'll take again same connection, I'll pass this thing. I'll mention somewhere already this there. What I need to go for it? I need to give one parallel connection to it. What is the value here? Z power minus 1. Right? For this what I can give? I can give one summer over here. So what I'm giving? I'm passing this one, this particular function by using one summer. And again here we should give one more summer. For that we are passing one line. For second parallel we'll give one more z power minus 1 and the same function we can pass to this particular summation. So this same thing we can add here. What I can write? I can add one summer and I'm passing to one more summer here, right? So this same function we pass it over here. So now tell me what is the value here? It is minus 3 by 2. Now minus 3 by 2 will become plus 3 by 2 here, plus 3 by 2. Similarly z power minus 2, what is the value? It's minus 1. Because there is no amplitude means 1 is there. That will become minus 1. This is minus 1. So what is the output like y of n? I can write. So this we did for numerator. So whatever the realization we are doing, we are going to concern this given function with this particular factor. So for that particular factor, if you want to write those values, I can mention in this way. So I can mention alternate also. It's minus 3 by 2. Here I am taking means I can take here minus 1 by 2. If I am taking minus 1 by 2 here, then what I can write here? Minus 3 by 2. This is the way also can do it. So if what I am doing, if I am giving 3 by 2, then what should I give here? I should give minus 1, alternate for this first factor, for the second factor. Now if it is giving 3 by 2 minus 1 here, what should I give? It's 3 by 2 with plus. Why plus? Because here minus. So see once again what we did. We had this question, we assume this as h1 of z, this is h2 of z. h1 of z only we are looking into numerator. In the previous question, we don't have the numerator, in that 1 is there. So that's what we only did denominator. Here first we are doing with numerator. So numerator if you do it, we had this particular factor first. So this z power minus 1, this factor will be here. Then 1 by 2 is here, that 1 by 2 we wrote it, z power minus 2. So z power minus 1, if you add on both of them, you'll get z power minus 2. So this is called as cascaded form. Cascaded form of given condition. So keep on practicing the questions with these particular combinations. So denominator we have not doing because both the and denominator are same. So the denominator is exactly same as the previous one. You can draw the denominator with the same value. This is how your realization of h1 of z and h2 of z has been obtained for given conditions. So likewise you write it down. For the first part I have explained, for second one you will see. For this part what we did students, so same thing is here minus 3 by 2 equate with 0, it has become 3 by 2. Here also we wrote 3 by 2, it's like alternate. Then it is plus 1 will become minus. So minus 1, z power minus 1, z power minus 1, if you add you will get z power minus 2 for the first factor. For second factor it will be here. And second factor if you add both of them you will get the first one. This side also gives same answer, this side also give you same answer. When you are writing twice for these, this is the second cascaded form. For h2 of z, this is nothing but h2 of z, right? What about this part? This is your first factor. This is nothing but h1 of z. So by looking into h1 of z, h2 of z, you converted the given condition into cascaded form. So in the next class, we are going to deal with the problem of FIR filtering. So FIR filtering, we are going to solve some problem based upon that, and we are going to start that particular part in the next class. In today's class, we discuss about cascaded form 1, cascaded form 2. Cascaded form 1 means only in the previous one we have seen denominator, only denominator we took and we found the value. Cascaded form 2, in that what we did, we had two values multiplied. This is the value they gave in the question, that one is h1 of z, h2 of z. This is called a cascaded form 2. So cascaded form 1, cascaded form 2, both we covered in today's class. So that's it about today's class. Thank you. You just check this thing, then we will continue in the next class, that unit 3.